Hello, math scholars. Mrs. Harp coming at you with another math lesson. Today we're doing 4.5. We're going to learn a few properties of logarithms. And it's going to be fun. Make sure you comment, like, and subscribe. Woo! Yeah, I believe I might have 13 subscribers now, so I think I'm halfway to 26. Woo! All right, our first property, and it's up to you if you want to write down the actual property on your notebook or if you just want to write down an example property, but this is called the product property. And the way it works is you can either expand a logarithm or you can condense a logarithm. But what you want to remember for the product property is that multiplication and addition are friends. So if you have a single logarithm with a multiplication between the m and n, a product, and you want to expand it into two logarithms, you would be adding these logarithms together. And then if you'd want to go backwards and you'd have two that you'd want to condense down to one, you would take it from adding and then you'd multiply them together when you condense them. That will make more sense after a few examples. Hello. No, there's no equal sign. So what we have here is log base 6 of 2 plus log base 6 of 108. There's an awkward space there, but there's no equal sign. So what we're going to do, let's go ahead and actually do that right now. We have two logarithms that we're going to try to condense down into a single logarithm. Now the first thing you want to verify is that both of their bases match. So these are both 6's. If this was a 6 and this was an 8, we wouldn't be able to do it. So they're both 6's. You can make them into a single log base 6. But you'll have to take the 2 and you'll have to take the 108 and multiply them together. So what is 2 times 108? And then just for fun and just for practice, after you condense, you want to attempt to solve it. Let's go ahead and attempt to solve this. 6 to what power would give me 216? So you might need a calculator to experiment that one. 6 to what power is 216? You figure it out? 3, 4, 2, 3, 3. You took your 2 and you held up this. 3. Okay, thank you. 6 to the third power is 216. There you go. So did you understand what happened with the condensing? They were adding, so I multiplied when I condensed. Go to the next one. Yes? No, these are ones you have to know. You can remember that adding and multiplying are friends. That's all you need to remember. Let's try this one. Are they both the same base? Are they both the same type of logarithm? Yes, they're both base 2 logarithms. So we are allowed to condense them into a single logarithm. Now, since they are adding, I will do multiplying. I will multiply the 32 times the 4. What is 32 times 4? 128. So it's condensed. Very good. We used our property. Let's solve it for fun. Okay? So to solve it for fun, we ask ourselves 2 to what power would be 128? 2 to what power would be 128? Experiment a little bit to get that. You figure it? Yep. Awesome. Yep. 2 to the 7th power is 128. That's right. Let's see what's up next. Oh, a new property. So this is called the quotient property. The thing to remember about the quotient property is that division and subtraction are the two operations that go together. They're friends. So if you're expanding a division problem, you'll subtract. And if you're condensing a subtraction problem down, you would divide. All right, so we got our condense. We have two separate logarithms. We're going to condense into one. They have a subtraction sign, so I have to remember that subtraction is friends with division. What is 40 divided by 8? 5. And then we learned yesterday that if this number here matches this number here, what do? You can just cancel it out because it equals 1. Because 5 to the first power is 1. So that one worked out well. Moving on. This is my favorite property because it's all about the leapfrog. So you go ahead and write down the property, and I'll give you a treat. I've got some frogs here to visit today.
What is that?
Write the property down, students.
That scared me so bad.
Just like an August night in Ohio, because it's August birthday appreciation day.
It sounds like a movie chair. I think everybody's stepping right now.
Alright, so here's how the leapfrog property works. You're probably wondering how does it work. When you have a log of a base, and then you have a big number here, if that number has an exponent, that exponent is allowed to leap either out front and live out front, or if he's living out front, he's allowed to leap back and go into the exponent position, depending on what you're trying to do to solve the problem. So you can leap him to wherever you do. Okay. Leapfrog property called the power property. You want to try one? An example? All right, go ahead and write it down. We'll try. All right, so since our job is to condense this into a single logarithm, I always say look for the frogs first. Do you see any number that we can leapfrog up into an exponent position? Spencer?
2.
Good. So this 2, I'm going to leapfrog up, and it will become 3 squared. And this 4, I'm going to leapfrog up. It's going to become 3 to the 4th. So I'll go ahead and actually calculate those numbers. 3 squared is 9. 3 to the 4th is 81. And do my bases match? What is the base here? Good. What's the base here? So they do match. So if they're not actually there, I like to write them there just to remind myself, oh, it's a base 10. I can condense these down. And what would I do with my 9 and my 81? Multiply them, because adding and multiplying are friends. 729. And I would just stop there. I don't need to actually solve that one out. 10 to what power is 729? It's going to be a decimal. So just leave it. Yeah, we're going to do a lot more that involve frogs. Everybody ready? Okay. Oh, wait. Oh, yesterday we learned if there is no baby guy listed right there, it's a 10 automatically. It's called a common log. And so the button on your calculator, beside the 7, this guy, he's automatically a base 10. Okay, so this says use properties to condense and solve for P. So we're going to condense down this right-hand side, make it look like the left-hand side. I'm going to make the frog noise every time we have to use the leapfrog property. Because the frogs are helping me make my day happy. Great, so do you see any frogs to start us off with that? The 3. This 3 is a frog. This 3 is going to jump up and become the exponent for the 5. And I would go ahead and calculate out 5 to the 3rd, which is 125. Good job with your frog. All right. We can do further condensing over on that right-hand side. How can you combine those two logs? They're both base 10, by the way. We would multiply, because adding is friends with multiplying. So 125 times 2 is 250. Now, actually, we're done with the problem, because what we have on the left looks exactly like what we have on the right, so we can make a conclusion about P. If log P equals log 250, What does p have to equal? Right. So it's not like we divided to finish. It's not like we did left, right, center to finish. We just looked at it and came up with a conclusion. Okay? Yay. Yes? What do you mean? If there's ever anything left of the log? Oh yeah, anything that lives here, can you leap it? Yeah. And you can only leap it over one log, because frogs can't leap over two logs, so you can't like bring them over here. Okay. Because I often tell people frogs can only jump over one log.
Oh,
Because they're just little frogs.
Get a log and bring a log and
Yep. Perfect. Yep. All right. Right. This is a big one. It might take you a second to write it down, so I'll pause the video. Definitely gonna see a frog in this one. I'm sorry. You don't like frogs, apparently. All right, we're ready to start this one. Do you see any frogs we can start our day with leapfrogging? The 1/2. So let's leapfrog the 1/2 up. It's the exponent of 25. So make sure you do 25 to the 1/2 to figure out what that equals. What is 25 to the 1/2? 25 to the 1/2 should be 5. So I say we got 35. Oh, okay, good. It's 5. Now, right away, I was like, oh, sweet! This is a cancellation property. We learned that yesterday. Because 5 to the first power equals 5, I can just cancel this out, and it has the overall value of 1. All right? What's going to happen over here when I try to condense down these two logs? They have a minus sign between them.
So it'll be division.
Division. Perfect. So we have to do 85 divide by 17 when we condense. And does that give you what? No way! What did we just talk about? We can cancel that. It has the overall value of 1. So our final answer is 2. Crazy. Isn't that cool? That wasn't too much work. We just did an exponent and a division and then some canceling. I think it's fun. This is one of my favorite sections. Not just because of the frogs. We okay? Ready? All right, I'm just going to do the first 2 of these. In reality, if you are posed with a question like this, you would just use your special log button, right? That's what I would do. But I'm going to show you, since the book wants to show you, how you can utilize the properties of logarithms to solve something like this if you have some given information. So look at our given information. We are given that log base 4 of 3 is 0.792. And we are given that log base 4 of 7 is 1.404. I'm going to use this given information, and not even any log button in my calculator, to figure out the value of this guy. So, we're going to use the properties of logarithms. Since this is division, I'm going to expand it into 2 separate logarithms with a minus sign between them. Does that make sense? So just like we did condensing, you can also do expanding. And now, if you notice, we know the value of log base 4 of 3. It's 0.792, so we can substitute that in. And we know the value of log base 4 of 7 is 1.404. We can substitute that in. And you can just subtract those numbers and you'll have it. Well, Lauren did it for us. Negative 0.612. Yep.
If you need to do this family test, we just type in on the calculator.
On the calculator, just type it in. We're just practicing this for the homework to get you more usage with utilizing the properties. So do you understand how this division became this subtraction, for example? Okay. The whole goal of this lesson is to make you comfortable with properties. Oh, just 0.792 minus 1.44. Oh, this was given information to you. If you need to get it yourself, you do the math up button. You have the 83. Record. Okay, moving on to part B. I expanded my log base 4 of 21 into log 4 of 7 plus log base 4 of 3. Now I can substitute in the known values. 1.404 is log base 4 of 7. And 0.792 is log base 4 of 3. Lauren, hopefully you already typed them in for me. Awesome. 2.196. It's good that I have you seen. Okay, there's only one other concept to go over, and that's what I'm calling the Spencer-Lexi TI-83 concept. So it's called change of base. Let's say you guys were taking a test in science class or something, and you had a non-scientific calculator, like one of those TI-30s, and you didn't have access to the special log button, that math up button, but yet you had to figure this out. They don't have it. So a TI-30, a TI-83, they don't have that special button. It's just not a possibility. The only thing they have access to is this log button, which is a base 10. So what they do, and I want you to all be familiar with what they're doing, they do a log base 10 of 5 over a log base 10 of 2. This is how they type it in. So I want everybody to try that. So you're on your home screen. You're using the log button that's beside the 7. So you do log 5, close the parentheses, divided by log 2, close the parentheses. You don't actually see the 10, so I should probably erase that so you don't get confused. But that's how you can solve something that's not a base 10 with a base 10 button. Make sense? And if you ever need to Google this, Spencer, it's called the change of base formula. Yeah. Can you store log as a different number? Like, what do you mean?
You know how you can store X's in a number of logs?
Right.
You store log.
Base, like a log base 2 or something like that? No.
Should make that function.
Right. That could be convenient if you use log base 2 a lot. Does that make sense? So let's try one more using the change of base formula, which means you're not using your special log button. You're using the normal log button. How would we type this one in? Spencer? Five. Yep. Did you guys get 1.29? And if you want to check yourself, you can feel free to use that special button to check. I actually use the special button just to be like a checker for you guys. It's 1.29. Okay. What? So we can go ahead and be done. I'll stop the video and you can write the homework down. I would start it because you have like 11 minutes, so why not start it? Get some help.